Hey guys, and welcome back to a new video and a new course about dependency injection, this time using Koin. A lot of people wanted me to make a video course about Koin. I already have one about Dagger Hilt, which is a very common dependency injection library for Android. And now it's time to actually make a video about Koin as well. So you can watch both of these courses and then decide which one you actually like more. And I will actually structure this in a way that you don't have to know anything about dependency injection to follow through this. And because of that, I actually want to start talking about what dependency injection actually is, because most people actually overcomplicate it. It's really not complicated if you think about it. In the end, dependency injection is really just giving an object its instance variables. So let's think about that a little bit. Giving an object its instance variables. So an object is any type of class, like an instance of a class, and we pass some variables to that object. For example, in the constructor, that's dependency injection. That's really it. And the name dependency injection, let's think about that for a bit. So we give an object its instance variables. This giving, or this passing of variables, is called injecting. And the variables or objects we pass to another object are called dependencies, because the object depends on these objects that we pass. I think that makes sense. And let's now think about why that's actually helpful, because that's really one of the design patterns that I would really use in every project. There is no scenario I can think of where I would say no dependency injection, using that would be too overkill here. I would use it in every project for everything you do, because it's so easy to apply and it comes with such big benefits. And for that, I want to let's just create a little project structure here. That doesn't need to make any sense. I will just create a very common project structure. You don't need to follow along with this. I just want to show you something. And that is, I want to have a main repository. Or actually, you can follow along, just an empty compose project, because we will go on with these classes that I create here. Let's call that main repository implementation. I don't write the abstraction yet, like the interface for that. Let's just have the implementation, which will be enough to show you what I want to show you. And then a very common thing we do with the repositories is that we need them in ViewModels. So let's also create a main ViewModel here in our package called main ViewModel that inherits from ViewModel. Nothing special. And now if we want to actually access our main repository, which is usually the place where we either access our database, where we do network calls, stuff like that, we of course want to do that from within our ViewModel. So we now have two options to do that. Option one would be, we say private val repository is equal to a new main repository implementation. And then in here, wherever we have a function, like a do network call, like this, then we could say repository.do network call or so. And that would work. However, what is the problem with this approach if we do this? Because right now we don't apply the principle of dependency injection. Because we don't really give this view model its instance variables. No, the instance variables, which is the repository in this case, is created directly within the view model here. And by doing that, we force this main view model to have a main repository implementation here, which is immediately created. So there is no way for us to actually tell the ViewModel, hey, for this specific ViewModel instance, I actually want to give it a different type of main repository. And let's think about what it means if we actually want to unit test our ViewModel here. Then every instance of the ViewModel that we test has such an instance of the main repository implementation as well. And if that main repository implementation actually makes our actual network calls, it accesses our production database, then that's something we don't want to do in the test cases. In the test cases, we rather want to have a repository that kind of simulates that behavior, but we of course don't want to talk to our real API or save stuff in our real database every time we run our test cases. That would of course be super bad. So let's actually work on improving this approach. And for that, I will actually now add a little abstraction for the repository so you can understand that better. I will just create a main repository interface here. And let's just give it a little function do network call here. Nothing special, just to show you how that would work. Then in the main repository implementation, we make sure to implement this main repository interface. And here we can override this do network call function, which won't do anything here. And then here in the view model, we now want to apply dependency injection. So instead of actually creating the repository in the view model itself, we remove this line and we pass it in the constructor of the view model. So we say repository, and here we pass the main repository interface. And that way we are much more flexible now with what we pass to this view model and what the view model actually uses. Because now the view model only relies on the abstraction, like on the interface, not on the implementation. And by doing that, we can also create different versions of this main repository, which might not use our actual API, which might just simulate that network call for our test cases. And that way we can very easily swap these dependencies out, and the view model doesn't care what the repository actually does. And that's called constructor injection, because we inject these dependencies. The dependency would be the repository here in the constructor of our main view model. Cool. But this video is about Koin. Koin is a library to do dependency injection. So constructor injection is one way of doing that, but the other way is actually using a library that supports that, which comes just with a lot more features. I will go through this here. Don't want to overwhelm you already in the beginning. But yeah, there are other popular libraries like Dagger, Hilt. Let's just have a little comparison between Dagger, Hilt and Koin, because those are two very popular libraries in Android for dependency injection. Well, Dagger Hilt is actually a compile time injected library, which means the dependencies, like all of our objects, will already be injected at compile time. So as soon as we click run, it is already clear which dependency goes where and stuff like that. Because Dagger Hilt works a lot with annotations and annotation processing and generating some classes you don't see. And then these classes kind of provide the dependencies for example, for the view model. Koin, however, works a little bit differently here. Koin is not compile time injected, which makes it a little bit slower. So it rather provides these dependencies on demand when we already run the code. So when we run it, it will figure out which dependency goes where. However, please don't think that when I say Koin is a little bit slower, that this is a valid reason not to use Koin. Please really only consider the fact which dependency injection library you like more. This performance issue is really so insignificant that you won't realize it in your projects. So let's now actually set up some further classes here, because I want to now show you how to use Koin in a kind of real life scenario. Of course, this is just a blank project here and we don't have a real project, but I want to show you a typical scenario that shows you why dependency injection is helpful and how you can apply it in that scenario. And that is just that we have an API interface that comes from retrofit, common library to do network calls. Then our main repository will use that interface from retrofit to do the API calls. Our view model will use the repository, and then our activity will actually use the view model. So that is a typical chain of dependencies that you have in your projects, and I will show you how you can accomplish that with Koin and some extra features of Koin, which you might also often need in practice. And to make sure that you can actually follow along with that, make sure to have these 9 dependencies here actually. On the one hand, we have 4 dependencies for Koin, which is Koin Android. That is just the base dependencies and the base functionality of Koin for Android. We have Koin Navigation. I'm not sure if we actually need this, but that way you can kind of scope dependencies to your navigation graph. I don't think we need this here in this project. This one is needed for Jetpack Compose if you want to use Koin with Jetpack Compose, but even if you're not familiar with Compose, keep watching this video. This has nothing to do with Compose, and I will also show you how you can make use of Koin with XML, because an activity, in this case it's kind of both, because activities are used in XML and Compose, and we don't really have composables here anyways. If you want to test with Koin, that's something I won't go into here, then you need this test implementation dependency, and we have retrofit for just showing you one example of dependency injection, and of course the view model stuff. So we are able to create view model instances. Without further ado, let's go to our root package and create a new retrofit interface. I'll just call it my API. It won't do anything here. It won't talk to real API. I'll just have a single function. Let's call it call API. And we say, okay, that's a GET request. Just a very common thing you have with retrofit. And here you have my endpoint, which this API would call. Okay. Then, of course, your repository implementation, which would do this network call, needs an instance to the retrofit interface. And what we already have learned is that we should provide this in the constructor here and not create directly in the main repository itself, because that would not follow the principle of dependency injection. So instead we save private val API of type myAPI provided in the constructor. And that way we could also theoretically swap this out with a different type of myAPI. And then here it would just call API and do whatever kind of response and error handling, which we don't want to go into here. Cool. In our main view model, we already rely on the abstraction of our main repository, which is fully correct. However, there's of course one problem now. And that is, how should Koin actually know how our API should look like? So our retrofit interface, how should it know what the base URL is? How should it know whether we want to use some kind of converter factory? Just how it's built. It can't know that. And that's something we need to tell Koin. And that's something we also need to do for Dagger Hilt. And that is called, we need to provide a dependency. We need to provide an instance of this myAPI so that Koin in the end is able to inject this myAPI at any place we want. And the way we do this is we define a so-called module. That is a very common concept when it comes to dependency injection. So let's just create this and then I will explain how that works. In the root package, we have an app module. I will call it like that. Select file, and that will just be a normal Kotlin variable, which we can create with a module. And then we have a block here of code. So in this module block, we now need to tell Koin how we want to create our dependencies. And there are different types of how we would like to create our dependencies in different scenarios. A very common case is that we use what is called single. And when I write that, I don't want to talk about the life of a programmer. No, that actually means singletons. So a singleton in the end is just an instance of an object that only exists once during our whole application lifetime. So if we, for example, take a look at our API interface, then we don't really need to recreate this instance in the project. It's totally enough if you just create this once and then use the same instance all over our project. So that's what we want to do in the single block. Now here, we need to return an instance of the dependency we want to provide. So an instance of our myAPI interface. We can do this with retrofit.builder. We need to provide a base URL, which, yeah, it's not intended to work. Let's just provide Google here. So it's a valid URL. Let's add a converter factory, for example, if we would like to have that. Marshy converter factory is what I included in the dependencies. And then we can say that build and that create, which will return the actual myAPI interface. So that way, we now told Koin how we actually create our myAPI interface. And from that point on, Koin will be able to actually use this exact instance we created at this point in our code and inject it here in our repository in the constructor. So that's now Koin's job. However, it now still doesn't know how to create this repository, which is actually needed in the main view model. So when it tries to inject this main repository here, well, it will take a look in the module and it will see, okay, I actually know how to create an API, but I don't really know how to create a repository. And that's the next step we need to do. So we need to do the same for our repository. So again, single. And here we now create our main repository implementation that we want to provide for the main view model to be injected into there. And well, now that main repository actually needs our myAPI. So how do we now take this instance and put it here in the constructor of main repository implementation, which that one of course needs. And that is where the get function comes into play, which we have access to in these scopes here. And what this will do is it will simply tell Koin, okay, you know what? I already provided this dependency that I need here, so the interface. Please take a look where you can find it and then take that instance. So Koin will see, okay, Philipp actually wants to get this my API interface, and it provided it here, so it will take this instance and pass it here for instead of this get function. And that's really almost everything you need most of the time with Koin. There's still another function which works a little bit differently from single, and that is called factory. What factory will do in comparison to single is it will create a new instance here of this main repository implementation every time that is requested. So let's say we have two ViewModels and both request a main repository instance, then this factory block will give each ViewModel its own instance. However, if we use single, it will create a singleton, so just one instance, and it will reuse that for both ViewModels. Usually you're totally fine with single. I will come to another concept which you might need sometimes, which works a little bit different from single as well. But for now, we're fine with that. However, there's one more thing we need to take care of here. Right now, Dagger Hilt, Koin will think that we actually provide a main repository implementation here, which we actually do. But in the main ViewModel, we try to inject the abstraction, the interface. So we need to make this explicitly clear here that we actually want to provide this as the abstraction by specifying that as a type. Otherwise, Koin will complain later. Cool. So now Koin also knows how to create our repository. It knows how to create our API interface. But one thing it doesn't know, and that is how it should create our ViewModel and actually inject that into our main activity where we can finally use that instance. And that works a little bit different from single because creating a ViewModel is not just calling the class name with a constructor. No, there's actually a factory behind the scenes, which you would not normally see and normally would need to implement, but Koin actually does that for us. However, we still need a different function here, which is just ViewModel. We want to provide an instance of main ViewModel, which we actually don't need to specify here. We can just create a main ViewModel. You can see now that takes our main repository, and because Koin already knows how to create this main repository, we can simply call get here as well, just like we did here. And now it also knows how to create our main ViewModel, so we can inject that finally in our main activity. How do we now actually inject something? So now we have learned how we can provide dependencies so that Koin knows how to create these, but we haven't learned yet how we can inject these into our classes. So if we go to main activity, for ViewModels that actually, again, works a little bit differently than for normal classes that we would like to inject. Let's start with ViewModels, because most of the times you're just going to inject ViewModels and all the dependencies you have go inside of the ViewModel. So we will have a private val ViewModel here, and we just say by ViewModel. And we use this function, and that is an instance of main ViewModel. And that will automatically provide the ViewModel instance we provided here in our app module, this one, here in the main activity, so we can use it there. That is the way how you would do it with an XML project. If you have a compose project, you don't need to do it this way. Instead, you can just go inside of your composable and you say, I want to get the ViewModel here, and that is equal to get ViewModel, this composable function here. And that again is a main ViewModel. Oops, main ViewModel. And then you could also use that in your composable function. So those are basically the two different types how you can inject ViewModels. But what if we want to have another dependency here in our main activity that's not a ViewModel? Let's say we want to have an instance, or we want to have the instance of our API interface in main activity. This is something you, in a real project, you shouldn't do. You shouldn't mix data and presentation layer, but just to show you how you would do that if you would have another dependency. Could be any type of object, and you want that in your main activity. Then you would simply do it like this. Private val API is equal to actually get. So we again have this get function. That would be one way. And we say, what do we want to get? We want to get our MyAPI. By using this get function, that's actually like an immediate injection. So as soon as our activity is created, it will inject that MyAPI, and it will also construct this instance here of this MyAPI as soon as our activity is created. However, what you usually want to use is by inject. This one here. You say MyAPI. That's actually called lazy injection. So it will only inject this API interface, and it will only construct this here once you actually use this API variable for the first time. And that can sometimes be very, very useful if you, let's say, you need to provide some kind of service or so that talks to an API, and that service needs a token. The token first needs to be fetched, so there is a little bit of delay in a network call. So you don't want to inject that service immediately. No, you actually want to lazily inject it and only use it once the token has been fetched. Just one example why that's usually helpful, and usually there is no downside in using inject. So I will remove this again, and let's just see if this works. Let's go to our view model and say, okay, let's not do the network call here. I think that will crash. Let's just print something. And in main activity here, we just say view model, not do network call, which would just print something here. You also shouldn't execute this directly in a composable, but it's just to see that the view model is properly injected and passed here. If we launch this, you don't need to see my device here, because we would have a blank screen anyways. We just want to see our logs. So let's open these, and hopefully, actually this won't work. Like it will probably crash because I forgot something, something very important. And that is we need to set up our application class actually, because we haven't really initialized Koin yet. Good to not forget about that. In our root package, let's call that my application and select class here. And that's an application class, because when our app is actually created, we want to initialize Koin. So we do this by using start Koin. Here we have a block, and we now need to tell Koin on the one hand what our modules are. So we could have multiple modules, but it of course needs to know that this is our app module, which is currently an unused variable. So that's something, of course, that we need to provide here. And something else is we want to call something like Android context. And here we want to pass this application instance. So what is that useful for? Well, if you actually need to inject the application context with Koin, then it of course needs to know where it can get that from. And it can get that from this my application instance here. So you basically tell Koin here, you get my application context, and from there on it will be able to inject that in some constructors of your dependencies. You might need that in. And if you want to use the logging feature of Koin, you can also install the Android logger here, which is optional. We then want to go to our manifests and provide the name attribute and pass my application. So we register it here, so it's actually used. Now we should be fine to execute this. Let's see in logcat. And here you can see it actually prints something. So the injection is working perfectly fine. However, there are still two more concepts that I want to show you here. On the one hand, and that is the concept of scopes. So in our app module, we have this single function, which again just creates a singleton instance. So there will be one instance, and that lives as long as our whole application does. However, very commonly, you actually want to kind of scope your dependencies that they don't live as long as your whole application does, because you might only need them in an activity. So why should they actually be kept in memory if the activity is destroyed? There's no reason for that, and that is why we can actually create a different module here, which I will call activity module. Val activity module is equal to a new module again. And what we can do here is we can now have another set of dependencies that we provide, and they only live as long as the activity they are injected into. So how can we do this? We can say scope, and here we need to provide the type of the class we want to scope this to, so main activity. And in here we can then say scoped, where we need to provide the dependency we actually want to scope. I will do something super simple here. I will just inject a simple string, hello, and that way we scope this hello string just to a single activity, to our main activity. And once that's destroyed, the string will also be garbage collected. So we need to go to our application again, because we created a new module, which we need to tell Koin here. And then we go to main activity. What we need to do here in the activity, we actually want to inject the dependency we scope to this. We need to implement an interface called, I think it's Android scope component. And then you can see we need to implement a function here, which is called scope, not a function, just an object here, a field. And well, what is the scope? Here we can simply say by activity scope. So if we now actually inject our dependency, our string, our hello string, we can do this using private val hello by inject, and that's a string. Then this hello string is now properly scoped to this main activity. If we go here and we say print line hello, then hopefully we see this hello in our logcat. Let's search for that. And there it is. You can see hello is printed in the console. So we now properly scope this to our main activity. We properly injected it here. There are, of course, some other scopes as well. For example, another common one is the activity retain scope. So that would be kind of the ViewModel scope, because it's this will keep this hello string even when your activity rotates, which destroys it, but it kind of survives that, the dependency. If we use the activity scope, it would be destroyed when the activity is rotated or there's any other kind of configuration change, and then recreated and re-injected once the activity is recreated. There are other Android component scopes like service scope, I think, fragment scope. Yeah, so feel free to play around with that. One last concept I want to show you is actually the concept of qualifiers, because some of you might already think, what happens if we actually now have two different strings we would like to inject? How does Koin know which one it should inject here in this hello variable? And the answer is it can know that. And the solution to this problem is that we use so-called qualifiers. So in activity module, let's say we have another dependency by that we inject here. And now we have two strings that we inject in the same activity, and we don't specify which one we want to inject here. So Koin will have a conflict here because it doesn't know which one to take. And the answer is we can provide a qualifier here as a parameter. We can say named, and we can simply give this a name. And then we can refer to this when we inject it using the name again. So again, named, and this one is by. We go to main activity, we go inside of inject, and here we can again pass this qualifier, and this time we want to inject the hello string. If we then relaunch this, take a look at logcat, then this time it actually crashed, I think. Did it? Okay, so that's just an issue with the activity retain scope. It wants an app combat activity, it's a component activity. Seems like that doesn't work with compose, but there's also no real reason to use that in compose, I guess. So let's just remove the scope stuff here to show you how, actually we can't remove this, but we can use activity scope. That should hopefully work. So logcat, did this crash again? No, here we have our hello string. And if we now swap this qualifier out for by, we launch this, and then we of course don't find it by switching for hello, but you can see here's our by text. So that's how you can tell, not Dagger Hilt again, how you can tell Koin which dependency should be injected into which object. And if you actually also want to learn about Dagger Hilt, where a lot of these concepts will now be familiar to you, then you don't want to miss this course, which I already recorded about that.